So in this episode we're going to be looking at points of intersection. So up until now we've just been looking at a single linear equation and how we can calculate values around that single linear equation. In this episode we're going to start looking at what we can do with two linear equations. So, in case you didn't know, we can graph multiple linear equations on the same set of axes on the Cartesian plane. And well, one question you might be asking is why? Well, let's consider the following. We have two phone plans that we want to compare with a certain call rate. For calling a few people, one plan might be cheaper than the other one, but for placing many calls, the other plan might be cheaper. So what we can do is we can compare the plans, work out where they intersect, and work out which plan would be cheaper for you based on how many calls you place. So this is a great thing with linear algebra, because there might be a constant call rate or some kind of linear equation representing the call rate that you could actually do to find this out. And that's just one of the examples. There are many more contextual examples of why it might be useful to do this too. So of course, finding the point of intersection can be useful, and it's generally useful for optimization as well, which is another good application. But our question says, find the point of intersection for y equals 3x plus 7 and y equals 4x plus 2. So that's what we're going to be looking at. So we're just imagining two lines plotted on the set of Cartesian axes, and we want to be able to work out where they cross. What we essentially do is set the two equations equal to each other, and then isolate for a common x value. Because you know, well, if the two functions are intersecting at some point, then they're going to share a common x value. And that's essentially what you want to find, because when you can find that x value, all it is a matter of doing is substituting in the x value into one of the equations to get the y value, and you find where they intersect. Excellent. So, we know that we need x1 to equal x2 at the point of intersection. That's the key thing that we need to start with. So what we do is we set our two functions equal to each other. So again, we're just setting our two linear functions given in the question equal to each other, and we're going to algebraically rearrange and manipulate them. So the first thing we're going to do is we're going to bring this 2 across to the other side. We do this by subtracting 2 from both sides. 2 take 2 is equal to 0, so we're effectively cancelling off plus 2 from that side, so we just got 4x on that side. But of course, what we do to one side of the equation, we must do to the other, and as a result, we are subtracting 2 on the other side of the equation. And this leaves us, when we do the math, 7 take 2 equals 5, we get 3x plus 5 equals 4x. Excellent. So now what we need to do is we need to actually get this 3x here and actually move it to the other side, because we want x to be on one side of the equation. So what we do is we subtract 3x from this side, and that gets rid of it. And when we take 3x from this side, we end up with 4x take 3x. If we have 4 lots of some quantity, and we take 3 lots of some quantity, we have 1 lot of that quantity left. So x, therefore, just equals 5. We've found it. X equals 5. That's the x-coordinate of the point of intersection between these two lines. Okay, so what we do now with this is we actually substitute in that x equals 5 into one of the equations. I just picked this one here, as you can see. I'm just doing 3x plus 7, substituting in x equals 5, and I get 3 times 5 being 15, plus 7 equals 22. So as a result, once we substitute it into one of the equations, you can put it in that one. You'll get exactly the same result out as well. You both get 22 in both circumstances. But we write the coordinate point for the point of intersection, and it's x equals 5, y equals 22, so it's 5, 22. And that's really what the point of intersection is all about. It's just a matter of finding where two lines cross each other. Thank you for watching. Join us next time. However, if you need more practice or more support, check out our apps on the App Store. They have great worked examples, they have incredible worksheets and other materials that can help you really ace exams. We have Formulae for iPhone and Formulae for iPad. Also check us out on Twitter and Facebook to keep up to date with all the educational material that's coming out. Thank you.